Um, in this video, I will use implicit differentiation to solve for dy dx. I'm going to consider a typical example that my students from Calc 1 were asking me. So this is how it goes. So of course the topic is use implicit differentiation, which means derivative, to solve for dy to dx, or simply you can say y prime. I'm going to use dy dx, but they can be used interchangeably. So the question says the cosine of x times y equals y squared. Okay, so cosine of x times y, or simply xy, equals y squared. So when we use implicit differentiation, we will differentiate both the in terms of the x and the y, kind of. Differentiate cosine, the derivative of cosine is negative sine, so this will be negative of sine, whatever is the input, so in this case, xy. So using chain rule, I'm going to use the bracket, I'm going to differentiate xy. So notice that when we differentiate xy, which is x times y, we're going to use product rule. All right, when we use product rule, we keep one as a constant, differentiate the other one, and reverse. So I will differentiate the x, and that will give me 1, but then I will keep the y, so times 1, plus, and then I will keep the x as a constant, differentiate the y, which will give me dy to dx, or dy dx, equals, the right hand side is y squared. Power rule tells me I would have 2 times y. Of course, the degree is reduced by 1, but since it is y means a function of x, I will also get dy dx. So I'm almost there. The only thing left now is a little bit of algebra to solve for dy dx. So in order to do to solve dy dx, we need to get all terms that have dy dx on one side. So I will need to distribute. So this will be giving me negative sine xy times y. That's going to be negative y sine of xy. It's much easier to put the y, or negative y, on the front side as a coefficient. Then I will have minus, then I will have x times sine of xy dy dx. So I'm basically distributing this over this guy. That will give me equal to 2y dy dx. Okay. So I have one term that doesn't have dy dx. I have two terms that have dy dx. So I think it's much easier to take this term to this side, and we use change side, change side, change sign. When you change side, change sign. All right, so that means that this will be minus y sine of xy equals, let me write this one, change side, change sign, so therefore this will be 2y dy dx plus x times sine of xy dy dx. Like we said, when we change the side of this one, which was negative sign, to the right hand side, it becomes plus. Whatever was minus becomes plus. And of course, a couple of steps to go. I'm going to factor the dy dx in order to solve it. So I will factor this out, factor dy dx out. All right, I'll put it right here. So that becomes negative of y sine xy equals 2y plus x sine of xy times dy dx. Wherever you put it, it doesn't matter. I will have the dy dx here. Then all I'm going to need to do is, of course, divide both sides by this, and I'm done. So therefore, I can solve for dy dx, negative y sine of xy divided by 2y plus x times sine of xy equals dy dx. Pretty much we're done. If you want to put the dy dx on the left side, you can do that. It's a reflexive property. It doesn't really make any difference if you put it on the right side or on the left side. All right?